All right, we're back. We are still on page 288. We just had this major revelation where we figured out that we don't need to go through that limiting process for every x value we're interested in, because we could go through that limiting process, right? The limit as h approaches 0 of f of something plus h minus f of that thing divided by h. We could go through the process for just x. And when we do that, instead of getting a numerical value, we get a function back. And that function is called the derivative of the function. So derivative is in here. It's called the derivative. And the notation for the derivative, one of the notations, there's a lot of notations. The first notation that you'll learn for the first derivative, because we only did it once, you can actually do it more, right? Now you take the derivative and you do the process again. What do you get? The second derivative. You take the second derivative, you do the process again. What do you get? The third derivative. You can keep going forever in general, but eventually, for some things, you just get 0 forever. And we're going to see examples of that. Okay, so first derivative. And one of the things I want to show you before this is I'm going to switch over to the calculator. Just point out, like, the calculator can do basically everything that we can do, and it can probably do it better. So if I actually, I'm like in the problem. I think I have f of x defined somewhere. Maybe. Let me see. I'm going to start a new problem. Whatever. F of x colon equals x squared minus 1. All right. Is there any reason that I can't ask the calculator to find that limit? There is no reason I can't. So the limit as h approaches 0 of, what did I want to do? F of x plus h minus f of x over h. I'm expecting this to give me 2x. It does. But look, no reason, you can change this up. F of x is, I don't know, cosine of x. Let's see what the calculator says. Negative sine of x. What? Like, we don't, who knows? But the calculator will do it. So you can play around with your calculator and like work out some things, right? So f of x is the square root of x. Let's see. 1 over 2 root x. What the heck? Just, you know, try it. Just make some up. See what happens. So I wanted you to know that you could do that because it's a very cool thing. The calculator gives you the ability to explore these things before we talk about them in class. I do not object to that, especially since we like kind of physically don't have class anymore. Hopefully you're watching these in the far future when these are just supplemental materials to the actual class. But for now, a lot of this will be dependent upon your willingness to just like play around with the material and see what happens. So far, we have found that we can go through the limiting process. It gives us something we're calling the derivative. The derivative, the first derivative, tells you the slope of the curve. It has its own notation. There's a lot going on. So if I wanted to find f prime of 5, since I just figured out, we're answering everything for f of x is x squared minus 1. So if f prime of x we found was 2x, which means that f prime of 5, you just plug in, is 2 times 5, which is 10. The slope of f of x at x equals 5 is 10. 10 something per something, but we found the slope, right? And you could write the tangent line, all kinds of things. Slope of the line tangent to f of x at x equals -4. So this is where the slope of the curve and the slope of the tangent line are the same at the point of tangency. So you just get all these questions where it's like, how do you do this? How do you do that? It's all like terminology and it gets turned on its head and you just have to like really clarify things in your head. But if you keep track of things, I think you'll be okay. This question is saying, what is f prime of -4? So it's just going to be 2 times -4, -8. That's it. Look at that. We don't have to do the whole limit thing. You could have done, if you wanted to, it would be equal to, let me do this in a different color because this is like optional. There's no reason to do this, but if you did it, it's equal to the limit as h approaches 0 of f of -4 plus h minus f of -4 all over h. That limit definition there, that's how we found the derivative, that process. You want to memorize that. That's going to come up a ton. And the more you understand it, understand that it's the slope of a secant line, and then the 2 points go closer together. It equals f prime. Like all of those things. You got to get those into your head ASAP, as soon as possible. At what point does the curve have a slope of 3/2? So this is interesting. I know that f prime of x is the slope. So what I'm doing here is I want to figure out when f prime of x equals 3/2. Well, f prime is 2x, so that's 3/2, which means that x is 3/4. But did we answer the question? No. The answer to the question is a point. This is the x coordinate. So therefore, the point is 3/4, comma, f of 3/4. And let's think, that's 9/16 minus 16/16. So I think it's 3/4, comma, -7/16. Okay, make sure you answer the question when you're asked a question, right? So it's good. You were thinking like, oh, I know this slope of a curve is the derivative. The derivative we calculated was 2x. 2x would have to be equal to 3/2. You get x equals and you're all excited. And then somebody just rains on your parade and is like, you didn't answer the question. Don't be that person. Be the person who answers the question. For what values of x is the slope of f of x positive? This is an enormous idea, right? So the derivative tells us the slope. So we just need to know, this question is basically, when is f prime of x greater than 0? Because if f prime of x is greater than 0, then the slope is positive. Huge idea. And if the slope is positive, that means the function is increasing. So we're also answering the question, when is the function increasing? So when is f prime of x greater than 0? Well, if f prime is 2x greater than 0, when x is greater than 0. That's our answer. So what you might say is, since f prime of x is greater than 0 for x greater than 0, f of x is increasing, increasing, increasing on x greater than 0. So it's not really the question that we were asked, but like that's a thing you want to think about. So what I'm going to do is I'm going to stop this video here, come back and just talk more about this stuff. We're going to be talking about this forever. Like we're literally not going to stop for like a year and a half. So the sooner you start making sense of it, internalizing it, flashcards are not a bad idea. The sooner things will just make sense to you. So I'll be back in the next video and I will see you then.